So read this question. This is the simple question. You have to calculate the electric field at the origin due to infinite number of charges. Suppose this is the figure A. This is the figure A in which the charges are present Q, Q, Q and Q up to infinite. On the x-axis they are present, right? At this is the 1 meter, right? This is 2 meter, right? This distance is 4 meter, right? And the next distance will be equal to 8 meter. So you have to find the electric field at this origin. Suppose this is the y-axis and this is the x-axis. Up to infinity the point charge are placed. So because of this charge Q, because of point charge Q, what is the electric field? The electric field is kq upon r square. This formula we are going to use, right? So the principle of superposition we are going to use, mean at this point, because of this charge the electric field will be E1 in this direction. Because of this charge the electric field E2 will be in this direction. Because of this charge the electric field will be also in this direction, like that. So the resultant field at the origin is nothing but E1 plus E2 plus E3 plus E4, right? Like this. And this is equal to kq upon 1 square. This is the distance, plus kq upon 2 square plus kq upon this is the 4 square plus kq upon 8 square up to infinity. Is it clear or not, you tell? So this is equal to kq 1 plus 1 by 4, 1 plus 16 plus 164 up to infinity. This is the electric field at the origin along the negative direction, right? This is kq. What is this? This is the infinite series. So for the infinite GP, right? For the infinite GP, the formula is a upon 1 minus r. A is the first term. Over here a is 1, right? And r is the common ratio, and this is 1 by 4, right? Because 1 by 4 multiplied by 1 by 4 multiplied by 1 by 4. So it will be equal to kq, right? A upon 1 minus r, a upon 1 minus r, right? When you will simplify, the electric field is kq upon 1 minus 3 by 4, right? So you may write 4 kq upon 3, right? 4 kq upon 3 is the electric field, and in the direction, in the vector form, kq upon 3 minus I cap is the electric field due to this charge distribution, right? Copy this. So in the B part, right, this is the figure B. Here again the different charge particle are present at some distance, but they are alternative, plus q minus q plus q minus q, like that up to infinity. And this is the origin. This is the 1 meter, this is 2 meter, this is 4 meter, all right, like this. But because of this plus q charge, if you assume this is the electric field, so E1 is in this direction, and because of this charge the E2 is in this direction. Because of this charge the E3 is away from the charge. Because of minus charge the E4 in this direction. You understand? So the electric field at the origin will be, right, because of this kq upon, I am writing this side as a positive side, right? Kq upon 1 square, right? This side is taken to be the negative side, minus kq upon 2 square, kq upon 4 square, minus kq upon, right, the 8 square up to infinity. Is it clear? So if you take the kq common, this is 1 minus 1 by 4 plus 16 minus 64 up to infinity. So this S infinity is nothing but a upon 1 minus r. A upon 1 minus, what is a value is what? The a value is 1, the r value is 1 minus 1 by 4. So it is equal to a upon 1 minus 1 by 4 is equal to 4 upon 5. So this is kq 4 upon 5. This is the E naught, right? So the net, I am taking this direction is positive because the electric field because of this q charge will be maximum since the distance is minimum. So I am taking this charge is, this direction is, if I take the positive, so the net electric field at the origin will be in this direction only, and this is the electric field in negative x direction is 4kq upon 5. So if you write the electric field in vector direction, right, so it is in negative x direction, right. So you may write 4kq upon 5 minus I cap. So this is the electric field due to this system of charge particle, right. Copy this. So read this question. In this question, a charge particle is kept in equilibrium in the electric field between the plates of the Millikan oil drop experiment. You can think that if there are the two plates, one plate having the positive charge, right, and the another plate have the negative charge. So between the plate, the electric field from the positive to negative plates are produced due to the, right, wait for 1 minute. You may assume this is the positive plate and the upper side is the negative plate. This is the positive and this is the negative plate. So the direction of the electric field is from positive to negative, that is the downward. This is the electric field. The Millikan oil experiment was, right, the electron, if this is the electron, if you hang the electron, if you drop the electron in the air, because of this mg it will fall down. So to balance this electron, the electron has the negative charge, the electric field is applied in this way. If the electric field is applied in this way and the charge is minus q, so where, in which direction the force will be acting? The force will be acting QE in opposite direction. Is it clear or not? So I'm writing the q is what? The minus E, right, but I will take the only the magnitude because its direction is upward direction. So for the equilibrium of the electron, the electric field is produced between the plates. So if the electric field is E, which is produced between the plate, the mg will try to fall it down, but it is balanced or countered by the electrostatic force applied by this electric field, which is equal to q into E, right. So although you may write it is the q into E is equal to mg, what is the q? Q is the charge on the electron, so E into E is equal to mg. So if the direction of electric field is reversed, the calculate, okay. So this is the value of the, for equilibrium, right. For equilibrium, mg is balanced by QE. So in this case, the electric field comes to be q mg upon E. Is it clear or not? Now in the later part, it is said to be that the direction, if the direction of the electric field between the plate is reversed, now if it become positive plate and it become negative plate, so direction of electric field will be reversed from vertical upward. Is it clear or not? So if this is the minus E, already the mg is acting, mg was acting already, but now because of this electric field, another force q into E will be acting downward. So therefore it will have some acceleration A. So the net force is equal to m into A you have to apply. What is the net force? Mg plus q into E is equal to m into A for acceleration, it will down. Here the acceleration is 0, but this time there will be some acceleration because mg and the QE are acting in the same direction. The value of the QE what was mg, because it is balanced in the previous case, so it is equal to m into A. So 2mg is equal to m into A, mm cancel out, so acceleration will be equal to what? 2g. So therefore the acceleration of this electron will be vertically downward 2g, right. Copy this. So read this question. In this question you have to calculate the electric field intensity that is sufficient, just sufficient to balance the weight of an electron, right. Previously we have done, if the electron is hanging in air, right, so the electric field direction must be vertically downward because the force QE will balance the mg and the force QE will be on the negative charge acting in opposite direction. So what is the value of the, for equilibrium, right, for equilibrium, right, what is the condition? Q is equal to mg, is equal to mg, right. I'm writing the q magnitude only, not the minus sign. right? E, what is the M? M is the mass of the electron, 9.1 into 10 to the power minus 31. G value is 9.8 and the charge is 1.6 into 10 to the power minus 19 coulomb. So when you will solve this data, 5.57 into 10 to the minus 11 electric field Newton per coulomb or volt per meter, right? You may also write, right? This is the electric field required to balance the weight of the electron. Is it clear or not? Now, in the second part, in the remaining part, what they are asking, if the electric field is produced by the second electron located below the first one, if this is the electron, and why this electric field is producing, because there is a one another electron, and because of this electron the electric field is what? It is producing vertically downward, right? This is the electric field. So at this point, right, at this point is suppose distance is r. Is it clear? So at this point, what is the electric field? Because of this, the electric field is in this direction. Is it clear or not? And because of this electric field, the minus charge is present and the QE, or you can say EE, force will be acting in vertical direction. So because of this charge, if this is the Q and this is the point P at distance P, if this is the negative charge, what is the electric field magnitude? Say KQ upon R square. So this electric field is nothing but KQ upon R square. Instead of Q, I will put the charge Q, right? I am writing the magnitude, you must understand, KQ upon R square. So the electric field is to be produced by this electron, 5.57 into 10 to the power minus 11. The value of K, 9 into 10 to the power 9. The E value is 1.6 into 10 to the power minus 19. This is the R square. So this distance you have to find, below which an electron to be placed so that it may produce the electric field, right, equal to this. Is it clear or not? So therefore the R square is, right, 9 into 1.6 into 10 to the power minus 10. It is in denominator 5.57 into 10 to the power minus 11. It is equal to what? 9 into, when you will simplify, upon 5.57, right? I am writing this side, R is equal to 9 into 16 upon 5.57, right? When you will simplify, so the approximately the answer you will get how much? I'm calculating this, right? First copy this, I'm calculating this answer. So it is approximately 5.08 meter, right? Approximately, right? Copy this. Let's see this question. In this question, a block having the mass 4 kg. This is the 4 kg mass, and it is placed on a frictionless surface. It has also the charge Q. The charge is 50 microcoulomb, right? And it is connected to the spring having the spring constant K, like this. Is it clear? And the value of the spring constant is 100 Newton per meter. The block lies on the frictionless horizontal track and uniform electric field, the E. The uniform electric field is equal to what? 5 into 10 to the power 5 volt per meter. Acts on the system as shown. Initially it is x is equal to 0. Is it clear or not, you tell? If this is x is equal to 0 and this is equal to the 4 kg, is it clear or not? So if this is the plus charge, tell me, right? And the electric field is present everywhere in this direction. Are you getting? Like this, electric field is acting in this direction. So what will happen, right? Because of the electric force, initial speed is 0, it will start moving, right? When it will start moving, there will be the situation like this. The elongation in the spring will be very much, such that this force is what? Say equal to QE. And after moving the displacement x node, right, the kx node will be produced over there. Is it clear or not? In this case, listen one thing, this is the mean position. This is the mean position. Mean position is what? The mean position does not mean the elongation in the spring is 0. Rather, the mean position mean, this is the mean position mean when the net force on the system is 0. And here the speed is what? Speed will be 0, right? Speed at this point at the mean position is 0. Then it will continue to increase its speed. Here the maximum speed will be there. And now the kx naught is equal to, at the mean position, kx naught is equal to what? Say q into e. Is it clear? But it has obtained the velocity. Because of this velocity, it will further move till the speed become 0. So from here to here, it will move like this, and it will oscillate about its mean position, and this is the maximum displacement. You understand or not? So how to find the maximum displacement? Please tell. The first part I am doing this side. How to find the maximum displacement? Maximum displacement is found with the help of the WET, work energy theorem. Who is doing the work? The work is done by this electric force, plus work done by the spring force. The initial speed is 0. The final speed when it reached to the extreme position is 0. So the k initial and k final is 0. So you can apply the WET to find this, right, maximum displacement from here to here. Total work is equal to k final minus k initial, right? Both are 0. So total work done by the electric field plus work done by spring force. What is the electric force? QE, and the displacement work is what? Force multiplied by displacement. Is it clear or not? Force multiply. What is the work done by spring? If you remember, it is equal to minus half k x final square minus x high square. So the initial, when there is no elongation, the initial elongation is 0, and the final elongation in the spring is equal to what? Kx max. So minus half k x max square, right, minus 0. Is it clear? So it is equal to minus half k x max square is equal to 0. So QE into x max is equal to half k x max ka whole square, right? So one power will cancel out. 2QE is equal to k x max. So what is the maximum elongation in the spring? Is equal to 2QE upon k. Is it clear or not? This is the maximum elongation in the spring. Listen one thing. Also in the second part, they are asking the elongation in the spring in the mean position. What is the equilibrium position of the block? Right. So the equilibrium position means this they are want to find. So in the second part, equilibrium, at equilibrium condition, kx naught must be equal to what? Say QE. So x naught is what? QE upon m. Right. Okay. The value is also given. I can put the value later, but first you have to understand this is the condition for equilibrium. So this is x naught QE upon m, right? QE upon k, not m. QE upon k. So listen one thing. This is equal to 2x naught. Although with the help of the simple harmonic motion, we understand, we know already, right? But we have found this once again. If this is x naught, this must be the x naught, and this x naught is nothing but the amplitude of the oscillation. Is it clear or not, you tell? Right. And the maximum elongation will be the 2 times of this x naught. So this is the maximum elongation in the spring, 2QE upon k, and this is the condition for the equilibrium, right? First copy this, then I will explain. So now you can put the value, the 2 into q. The charge is given as the 50 microcoulomb. The 50 microcoulomb. The micro mean 10 raised to minus 6, and the electric field is given as the 5 into 10 ki power 5 volt per meter, and the k, the spring constant, is given as the 100. So when you will calculate, you will get this the 0.5 meter, and if you simplify the q by k, it is just half. So 0.5 by 2 is equal to 0.25 meter. So this is the equilibrium position. Equilibrium position from the starting. Is it clear or not? Now, it will oscillate left and right, left and right, right? So what will be the time period of oscillation, you tell? In the SHM, we have done the spring block system. Whatever the force, the time period of the oscillation does not depend upon the acceleration due to gravity and other force present. It depends upon the mass of the block and the spring constant, and it is given by this. The mass of the block is what? The 4 kg. The spring constant is how much? It is 100, right? So this is 2 pi by root 25 is equal to 2 pi by 5, right? It is 0.4 second, right? 0.4 pi second is the time period. Is it clear or not? And what else is asked? And the amplitude. What is the amplitude? This is the time period, and the amplitude is nothing but amplitude. A is nothing but x naught is equal to 0.25 meter. Right. First copy this, then copy this. So read this question. In this question, the figure shows the regular hexagon and charge are placed at the corner, each of the vertices. You have to tell in which configuration the electric field is to be 0, right? So this is the first configuration. Here it is the Q, this is 2Q, 3Q, and this is the 4Q, 5Q, and this is 6Q, right? So I think you can analyze, you can tell that no, electric field is not 0 over here, right? Because if you consider this, right, this is the Q and this is the 4Q. So the resultant electric field will be in this direction, right? Because this is the 4Q. If you consider this is the Q, this is the 4Q and this is the 2Q, right? So the net electric field will be in this direction. In the same way, if this is the 6Q, this is the 3Q, the electric field will be in this direction, like this. So the net electric field may not be 0. I am not going to calculate the electric field, but the electric field, the value of the electric field will be the different, and the net electric field at the center, right, is not equal to 0. You understand or not? Right. This is the first part. In the second part, right, in the second part, this is the charge Q and this is the minus Q. Because of Q charge, the electric field is in this direction, and because of minus Q charge, the electric field is in this direction. The same electric field will be there. And if you consider this is the charge minus Q and this is the plus Q, right? Because of this plus Q charge, the electric field is in this direction. Because of minus Q, again in this direction. So this is E and E. And if you consider this is the Q and this is the Q, right? So because of Q charge, the electric field is in this direction. Because of this Q charge, the electric field is in this direction. So they will cancel each other. But here at this point, the electric field 2E is in this direction. The electric field is 2E in this direction. So the net resultant electric field is in this direction. Is it clear or not, you tell? So in this case also, the electric field at the center is not equal to 0. You understand or not? Right. First copy this. So this is the first and the second part. If you think the third part is like this. This is the hexagon. This is the 2Q and this is the 2Q. So if you consider, because of this 2Q, the electric field E1 in this direction, electric field E1. So cancel each other. If you consider this is the Q and this is the Q, the electric field is E2 and E2. They will cancelling each other. And if you consider this is the point, right, the 2Q and this is the 2Q. The electric field E3 and E3 will be cancelling each other. So here the net electric field at the center is what? 0. You understand or not, you tell? But if you consider the fourth case, this is the hexagon over here like this, right? This is 2Q and 2Q. So their effect is cancelling each other. If you consider this is the charge Q and Q, they are cancelling each other. But if you consider this is the 2Q and this is the Q, so they are not cancelling each other, right? Because of this 2Q, the electric field is in this direction, and because of this electric field is in this direction, right? This will be the, suppose the 2E and this will be the E. So the net electric field on the center will be along this direction. So therefore, in this case, the electric field at the center is not equal to 0. You understand or not? So which option is the correct option? So the third option is the correct one, where the option is correct option, where the electric field at the center is 0, right? Copy this. So read this question. We have the four equal charges are placed at the corner, right, of the ABCD. This is A, B, C, D, and this is Q, this is Q, this is Q over here. So first you have to find the force on the charge placed at the B. So you have to find the electric field first. The force is nothing but the Q into E. So at this point the electric field you have to find. Because of this Q, the square side is A. Because of this Q, the electric field is in this direction E. Because of this Q, the electric field is in this direction E. What is the value of the E? Say KQ upon A square. KQ upon A square. And because of this charge, the electric field is what? Assumed to be the E dash. It is A, it is A, it is A root 2. So the E dash value is nothing but KQ upon A root 2 ka whole square. This is KQ upon 2A square. Is it clear or not, you tell? So this is the point EE, and this is nothing but E root 2, right? Because it is 45 degree and this angle will also be the 45 degree. Fine. So this is the E dash, the E dash this. So this is E and E. The resultant is E root 2 plus. You have to add the E dash. So the resultant electric field is nothing but E root 2 KQ upon A square into root 2 plus E dash KQ upon 2A square. So KQ upon A square root 2 upon 2. Is it clear or not, you tell? So this is the resultant electric field. Therefore, if any charge comes on this point, the charge may be the, suppose the Q node. The force on the charge will be the Q node will be equal to charge multiplied by the electric field at this point due to the other charges. So first we have found the electric field at this point and then multiply by the charge. The net force may be written as Q node into E. This is KQ upon A square root 2 plus 1 upon 2. And but this Q node is nothing but the same charge Q is placed over here. So I am writing the Q node is nothing but only the Q. So the answer is KQ square upon A square, right? And multiply 2 root 2 plus 1 upon 2. This is the force. You understand? So which is the correct answer? The value of the K is, this is maybe written as 1 upon 2 root 2 upon 2. The value of the K is 1 upon 4 pi epsilon naught Q square upon A square. This is the force. Is it clear? Right. This is the 1 upon 4 pi epsilon naught Q square upon A square. So the C option is the correct option. Right. This is the one way to find the force on this. First find the electric field, then multiply by the charge present at this point, you will get the force. But the another way, by using the Coulomb's law directly, you can write. How? If this is the Q, this is the Q. So because of this, the force will be there. Because of Q, the force will be there. Because of Q, the force will be Q F dash will be there. So F and F, the F root 2 and F dash. Is it clear? So the resultant force is nothing but F root 2 plus F dash. What is F? The force between Q and Q, right? It is equal to KQ Q upon A square root 2 plus the F dash is what? This is A root 2 KQQ upon A root 2 ka whole square. When you will simplify, the same force you will get, right? We have done this question already in the electrostatics, right? Copy this. So read this question. In this question, the ABC is an equilateral triangle. This is the A, this is the B, this is the C. An equilateral triangle, the charge is placed and you have to find the electric field if this is R, right? If this is the charge Q over there, so because of this charge, the electric field is in this direction. Because of this charge present on C, is the electric field is in this direction. And because of this charge Q, the electric field is in this direction. So here the electric field is like this. This is the electric field like this. This is the electric field like this. Is it clear or not, you tell? Fine. So what is the angle between these three vector? Listen, 120, 120 and 120. Listen one thing. If equal force or the equal electric field are acting in this way and the angle between them is equal, right, the net resultant electric field will be 0. Whether the electric field is like this, the angle for electric field and the angle between each electric field is what, 90 degree, or whether it is 6 like this, right? If the 6 vectors are acting like this at 60 degree, 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 if F are acting 60 degree, then the resultant force will also be 0. In the vector discussion in the very first chapter we have done this. So although you can divide these 3 forces or the 3 electric field in the component, the resultant electric field will be 0. But directly without calculating, if 3 forces are acting at 120 degree or 4 forces are acting at 90 degree or 6 forces are acting at 60 degree, or if 5 forces are acting, right, 360 upon 5, right, it is 72 degree. If 5 equal forces are acting at the equal angle theta, then the resultant force of all these 5 forces will be 0. So directly without calculating by a theorem, right, you can remember this, right? So the net electric field at the center is 0. Copy this. So read this question. In this question, the linear charge density on the upper half of a segment of the ring, it is not the ring, either it is a segment of the ring, right, is the linear charge density is lambda. Here it is lambda, right, and on the lower half it is minus lambda. Is it clear? Like this. Are you getting or not? So the direction of the electric field we have to tell. Suppose this angle is to be the theta, right? Because of this portion, the electric field is in this direction, right? Like this. What is the magnitude? They are not asking. But if you consider this is the angle theta, right, and this is the negative part, so the electric field is in this direction, right? So here, this is the point, the electric field and electric field both are equal, and this is the E, right? This, suppose this angle is 2E, right? Although if this is the theta, it is in just mid, so it will be the theta by 2 and it will also be the theta by 2, but they are not asking the angle, all these things, only the direction, because this is the cost component will cancel out each other. Only the resultant electric field will be the 2E cos theta by 2 in this direction, right? So they have given this sign. This is A, B, C and D. So what is the direction of the electric field from A to C? Along, if this is O, along OC. Is it clear or not? So the C option is the correct option, right? So the net resultant field will be in this direction, right? Copy this. So read this question. In the given figure, you have to find the sign of the two charges if the electric line forces, this is the Q1, and the electric line of forces are like this. Is it clear or not, you tell? Right. So they are coming from the infinity and they are terminating at the Q1 charge. So this charge is the negative charge. While if you consider the Q2, So the electric fields are, okay, electric field are also coming towards this charge, like this, right, like this. So if it is coming towards the charge, then it is what? It is also negative. Is it clear or not? So which option is the correct option? A option is the correct option. Both are negative charge, right? Copy this. So read this question. An electron having charge E and mass m is moving in a uniform electric field, right? This is the uniform electric field, right? The electron may be moving anywhere, it is moving. So whether it is moving with lower velocity in which direction or the higher velocity in this direction does not matter. The force on the charge will be equal to what? Say Q into E. If you consider the magnitude, this is the force, and put it equal to ma. So what will be the acceleration? Say E upon m, right? E upon m. So the acceleration of the charge is E upon m. The C option is the correct option, right? Copy this. Read this question. The concept we have done already. A charge q is placed at the center of the line joining the two equal charges. Okay, this is the q and this is the small q, right? And the system will be equilibrium. You have to find the value of the q. Listen one thing. If you consider this the q and this is q, so because of this charge, the force will be F in this direction. Because of this charge, the force will be in this direction. So this charge particle is at rest or it is in equilibrium. So no need to solve all this thing because it is placed already in the mid. Suppose this distance is a, this distance is a. The thing is that because of this capital Q, the force F1 will be acting in this direction, kq into q upon 2a ka whole square. And because of this charge Q, the force F2 should be acting in this direction, and this is equal to kqq upon a square. To equilibrium of capital Q, the force F1 plus F2 must be equal to what? Zero vector, like this. So this is the F1, kq square upon 4a square plus k capital Q upon a square. Is it clear or not? Must be equal to 0. So therefore the kq square upon 4a square is equal to what? Minus kq upon a square. So q value, oh, small q value is equal to q by 4 minus q. So q is equal to minus q by 4. This charge must be negative and equal to minus q by 4. So the B option is the correct option, right? Copy this.